In today's topic, we are going to discuss about various graphs, that is position time graph and velocity time graph. Position time graph means it is a graph which shows the position of the body with respect to time. So it can be either distance time graph or displacement time graph. Distance time graph, you have to think like this: distance cannot be negative. But displacement time graph, when we draw the displacement time graph, the displacement can be negative or positive. Similarly, when I say velocity time graph, you can think about speed time graph and velocity time graph together. Speed time graph can be always positive, but the velocity time graph, the graph can be in the positive direction and also in the negative direction. So let us see first the position time graph. So in the position time graph, I first draw like this. This is the time, this is the position, and see, it's a straight line parallel to the time axis. What does this mean? It means that the body is at rest. That means here the position is remaining stationary. The time is going forward, but the position is having only one and only one value, this one. Body is at rest. Now, second graph. What does this mean? The position is changing continuously with time. So we can say that the body is moving with uniform speed. So I'll just write uniform motion. Uniform speed or uniform motion. And here you can see the body is moving away from the origin. This is the origin. Body is moving away from the origin. So okay, that is the second graph. Now third graph. What is the difference between the second graph and the third graph? Both of them resemble same, no? So in the third graph, the body is not starting from the origin. This graph is also uniform motion only, but the body is not starting from the origin. The body is somewhere at a distance away from the origin, and then the body is moving away from the origin. So please write it. You have to draw the graph, and when I am saying, you have to write the things below the graph. Okay, so draw the third graph and write the body is in uniform motion, but body is not starting from the origin. Write that. Body is not starting from the origin. Now, so for each graph, now I am not going to write anything. I will just say the graph and tell the explanation. So you can write the explanation in your notebook just below the graph. Okay. Now fourth one. What is this? This is also uniform motion, because graph is a straight line. So this is also uniform motion, but here the body is coming towards the origin. That is the difference. The body is coming towards the origin. Okay. Now fifth graph. What does this mean? Here you can see the slope of the graph is increasing. It's curved upward. So in the previous graph, that means graph number 2, 3 and 4, slope is constant. Okay, you can write there. In graph 2, 3 and 4, slope is constant. But here you can see slope is increasing. So this is the graph for uniform acceleration. Okay, this is the position time graph for uniform acceleration. And here also the body is moving away from the origin. Now next one, sixth graph. What is this? In the sixth graph you can see that the slope of the graph is decreasing, because first the graph is going like this, and then the graph is curving in this format, and then finally it will become parallel to the time axis. That means slope of the graph is decreasing, write that. So the body is decelerating. Okay, so this is the accelerated motion. The other graph tells the decelerated motion. Okay, and there also the body is moving away from the origin. Now seventh figure. What is this? Here initially the slope means steepness of the graph. Initially the steepness is more, that means slope is more, and finally the slope is reducing and it's becoming parallel to the time axis, which means decelerating. So this is the graph where the body decelerates, but the body is moving towards the origin. The previous graph, the body was moving away from the origin with deceleration. Here the body is moving towards the origin with deceleration, right? Uniform deceleration, the body is moving towards the origin. See, what is this? Eighth graph. Here you can see the graph is curving and it's coming towards the origin. Here it is almost parallel to the x-axis, then the steepness is increasing. Okay, think that you have seen many slides in Wonderla. So if you are sitting on this is the shape of a slide. You imagine if you are sitting here your speed is less, and when you comes here your speed is more. So that is the same way. So slope is less here, slope is more here. That means the body is accelerating and it is moving towards the origin. So you can write that the body is accelerating and it is moving towards the origin. So these all things are applicable for speed time graph and position speed time. These all things can be applied for distance time graph and also displacement time graph. Now, the graph that I am going to show now, this is applicable only to displacement time graph. This is not applicable to distance time graph, because I already told distance cannot be negative. So if I draw a graph like this, you can say that the body is moving with uniform speed or uniform motion in the negative direction. Okay, body is moving with uniform motion in the negative direction. You can write like that. Now see the 10th graph. What can you say like this about this? Here the slope of the graph is increasing. So you can say the body is accelerating in the negative direction. These graphs are applicable, 9th graph and 10th graph. They are applicable only to displacement time graph, not to distance time graph. Okay. So accelerating in the negative direction. Now again, think about this. Slope is decreasing. So the body is decelerating in the negative direction. Okay, body is decelerating in the negative direction. Please make sure that you are writing all the points that I am saying below the graph. Okay, you have to draw the graph, write all the points that I am saying there. Now 12. What does this mean? Look. Here the graph is uniform motion. The body is moving with uniform speed, right? But from 0 to t1, from the time 0 to t1, the body is in the negative direction and it is moving towards the origin. Okay, body is moving in the negative direction and it is coming towards the origin. And from t1 to the next time t2, I will mark here t2. From t1 to t2, the body is moving away from the origin in the positive direction. Write that properly. Okay, from 0 to t1 it is in the negative direction and it is moving towards the origin, and from t1 to t2 it is moving away from the origin. See, here time is not changing, but the body is having infinite positions. The body is having, this graph tells that the body is having infinite position at one time. Example, I am staying in this classroom, at the same time I am staying in the other classroom, and at the same time I am staying in the third classroom. Is it possible? No. So the body is, this graph tells that body is moving with infinite velocity, which is not possible. Write it properly. Body is moving with infinite velocity, which is not possible. Now the last graph. I just draw a shape like this. When I put a dotted line and I mark T1, you just see at the time T1, body is having two positions, here and here. That means I am staying in this classroom and at the same time I am staying in the other classroom. It is not possible. So here the body is having two positions at one particular time, which is not possible. Okay. So that's all about the position time graph. Now we are moving to velocity time graph. So velocity time graph means it is the graph that shows the velocity of a body with respect to time. The graph which shows the velocity of a body with respect to time. Write that. So I'll put V here and T here. and look at my first graph. I just draw like this. That means I am drawing the graph along the time axis itself. That means graph is the time axis itself. This is 0. So what does that mean? Body is at rest. So this is the velocity time graph for the body at rest. Write it. See, here velocity is having only one value. That means this value, which means the body is moving with uniform velocity. So draw the graph and write body is moving with uniform velocity. So here slope is 0. What is this? In the third graph, velocity changes uniformly. That means that is the graph for uniform acceleration. So write uniform acceleration. Slope is positive and constant. Write that also. Slope is positive and constant. Look here. Here velocity of the body is decreasing to 0. What does that mean? That means the body is moving with uniform deceleration. That means retardation. So this is the velocity time graph for uniform retardation. Okay. So here slope is constant but negative slope. That is why it is a retardation. Now next graph. What is this? Uniform acceleration in the negative direction. Okay, uniform acceleration in the negative direction. Right. What is this? As the time increases, speed is decreasing to 0. That means this graph is uniform retardation in the negative direction. Okay, uniform retardation in the negative direction. Look here. What is happening? At one particular time, the body is having infinite number of velocities. So you can write like this: the body is moving with infinite acceleration, which is not possible. So this graph is not possible. Similar type of graph we have drawn in the position time section also. There we told body is moving with infinite velocity, which is not possible. Here we are saying body is moving with infinite acceleration, which is not possible. Please note down the difference carefully in your book. Okay. So that's all about velocity time graph. Now let us go on to acceleration time graph. So acceleration time graph gives the acceleration of the body with respect to time. So you already know if the body is moving with uniform speed, or if the body is at rest, what is the acceleration of the body? 0. So when I draw the graph, when I draw the acceleration time graph, I will draw like this. Acceleration is 0. So this graph tells that either the body is at rest or the body is moving with uniform velocity. So please note that body is either at rest or moving with constant velocity. Okay. Now second graph. Body is moving with constant positive acceleration. So here acceleration is positive. Body is moving with constant positive acceleration. And next, what is this? Body is moving with constant negative acceleration. Okay, body is moving with constant negative acceleration. So you need to study only 3 graphs regarding acceleration time. Now I am going to say some important points. So when I am saying, you just write it in your notebook. So write as a note. First point, right, slope of the position time graph gives velocity of the body. Put number 1 and write, slope of the position time graph gives velocity of the body. Velocity or speed, okay, velocity or speed of the body. Now put number 2 and write, slope of the velocity time graph gives acceleration of the body. Put number 3 and write, area under the velocity time graph gives displacement. Area under the velocity time graph gives displacement. Put number 4 and write, area under the acceleration time graph gives change in velocity. Area under the acceleration time graph gives change in velocity. So that's all regarding this chapter. Okay, thank you.